All right, welcome students. Welcome to the Simplifying Radicals extension of class. I'm going to go quickly through some of the questions and you can ask me answers outside of the lesson, but I just figured I would go through a lot of these quickly. So in number 16, um, we have the same index here, the square root of 3. I'm sorry, the same radicand, square root of 3. So we're just going to combine these. So we have negative one of them, and we're going to take away 3 more. So we have a total of negative 4 square roots of 3. And we're done. Going on to number 17, we have 2 square roots of 6, negative 2 square roots of 6, take away 1 more square root of 6. We have a total of negative 3 square root of 6. We are done. Again, we can't simplify that anymore. Square root of 3 we can't simplify anymore. What we do have is negative 3 of them minus another one. So that's negative 4 square roots of 3 combined. And we're done. Number 19. We don't have the same radicands. Look at 8 and 18. Let's try simplifying them and see if we can get them down to the same radicand, and then we can combine them. So in the first one, we have 8. That's 4 and 2. The square root of 4 is 2, so I'm going to break this down a little bit more. Looks like we have a group of 2. So here I have the original 3 that was on the outside, one more group of 2 I pulled out, and what's left over is the square root of 2. That is going to end up being 6 square roots of 2. I'm going to write it right above. So 3 square roots of 8 is equivalent to 6 square roots of 2. And, whoa, not sure what happened there. 18, I'm going to do the same thing with 18. 9 times 2, it's going to be 3 times 3. We have the square root of 3. We have the original 2. We have a pair of 3's. We have a 2 left over. So again, we have 6 square roots of 2. So we do have the same index. They're right here. I'm sorry, they're the same radicand, the square root of 2. So that's a total of 12 square roots of 2. That's my final answer. 20, let's see, 8 times 3. Then I got 4 times 2. And I have 2 times 2 for 54. Let's see, 9 times 6. 9 times 6 is 54. 9 is 3 and 3. 6 is 2 and 3. I'm going to go and circle the ones that are pairs. So we have these, and these are left. So it looks like I have negative 2 square root of 6. The 2 and the 3 are left over. Those are left over. What I took out was the grouping of 2, and I took down my negative as well. Okay. And this one, looks like I'm going to group up the 3's. Looks like I have negative 2 left, the original negative 2. And I'm going to keep the 3. And these are left over in the radical. So it looks like my final result is going to be negative 2 square roots of 6 minus 6 square roots of 6, which is negative 8 square roots of 6. And I am done. Moving on to the next one. We have 20, that's 4 times 5, just 2 and 2. 45 is going to be 9 times 5, which is 3 and 3. So my original 3, keep my group of 2, and then 5 is left over. In this one, we have my original 2, we have a group of 3, and 5 is left over. Perfect. I can combine them. I'm going to have 6 square roots of 5 plus 6 square roots of 5, which is a total of 12 square roots of 5. And I'm done. Here we have, oh, it looks like the same thing. We have 20 and 45. I'm going to copy this work. The only difference, 20 and 45, the only difference is the numbers out front. This 3 is not a 3, and that 2 is not a 2. What we do have is a negative 2, so negative 2 times the 2 square roots of 5. In this case, I have a negative 1. That's implied that that's a 1. So it's negative 1 times that, 3 square roots of 5. So looks like I have a total of negative 4 square roots of 5. And we're going to take away from it 3 square roots of 5, which makes a total of negative 7 square roots of 5. All right. Try to write that a little nicer. All right. And we can keep going. Yeah, I'll finish these up. Okay. We have same terms here. We have a 1. So we have negative 2 minus 1 is negative 3. We are done. This one, 24 and 54. 8 times 3, I believe 8, 16, 24. Yep, so 4 and 2, 2 and 2. Looks like these are the same. I can pull those out. So negative 2, the original negative 2, multiplied by 2. What's left in my radical is a 2 and a 3. So 6. 2 times 3 is 6. And here, I have a 9 times 6. I have a 3 times 3 and a 2 times 3. Well, I can keep the 3's with the original negative 2. So negative 2 square root of, let me use, let me fix this. We have a negative 2, original negative 2, times the 3 I'm pulling out, and then we have a 2 and a 3, so that's a 6. 2 times 3 is 6. So looks like we have a negative 4 square root of 6. Take away 6 square root of 6, which is negative 10 square root of 6 total. All right, now we're at the multiplication ones. I did one in class. Remember, what's inside stays inside the radical, what's outside stays outside the radical. So we have this one. There's only 1's on the outside. They're implied. So 1 times 1 is 1, so I don't really need it. I'm just going to do 12 times 6, which is 72. I just need to simplify it now. So 36 and 2, 6 and 6. What I can pull out of it are the 6's. So 6. I don't have to go any further. I could if I wanted to. I could break 6 down into 3 times 2, and then the other 6 into 3 times 2. But I might as well pull it out before we have to factor all the way down. So we have 6, and what we have left over is the square root of 2. And we're done. Looks like I did number 27 in class, so 28. Here's a good one. So we have 4 square root of 20 times 3 is 60. 60 breaks down into 4 times 15, which is 2 times 2, and then 2 times 3 times 5. Looks like the only thing we have in common are the 2's. Don't forget your original 4 out front. So we have 4 square roots of 60 ends up being equivalent to 4 times 2 square root of, looks like 15 is left over. 5 times 3 is 15. So it's 8 square roots of 15. All right. This one's easy. The square root of 25 times the square root of 25 is going to be 25. And then we have a negative out front. But let's just do the algebra. So we get negative square root of 625. That factors into 25 times 25. So like I said, once you see a group of 25s, you don't have to break them down further. We have negative 25. That's my answer. Again, could you break them into 5 times 5 and then 5 times 5? Sure. You're just spending a lot more time doing something you really don't need to do. Okay. 30. We have 2 square root of 20 times 20 is 400. Ironically, 400 is composed of 20 times 20. So we are done. 2 times, we pull out the 20 times 20, which is 120. So we now have 2 times 20 is 40. So again, 2 square roots of 400, really a square root of 400 immediately is the number 20. So we could have just done 2 times 20. Again, you have this 20 times 20. It's the same thing as 20 squared. Finding the square root of 20 squared, they cancel each other out. You have just a result of 20 left over. All right. We have 31. Looks like we have negative 3 times negative 5 is a total of 15. The square root of 15 times 5 is 75. So when I break this down, I get 5 and 3. I'm sorry, 25 and 3. And then I get 5 and 5. It has those in common. So here's my original 15 on the outside. Here's the 5 that I am removing. And then we have 3 left over. And that ends up being 75 square roots of 3. We're done. 32, we have 4 square roots of 25, which ends up being 4 times 5. Here's my original 4 times the 5 that was pulled out of the radical with nothing left in the radical, so we get 20. We have 15 times 8. That's 120. So we have the square root of 120, which ends up being, we can do a lot here. Let's do 12 times 10. 12 is 4 times 3, which is 2 times 2. 10 ends up being 2 times 5. It looks like there's going to be quite a bit left over under my radical, and that's okay. You know what I do have? I have a group of 2's. So that comes out of the radical. But what's left over? We have a lot. We have a 3, we have a 2, and we have a 5. So 3, a 2, and a 5. That's what's left over. So the only thing that came out was a 2, or the square root of 4. And it looks like I have 3 times 2 is 6 times 5 is 30. So we are left with the simplest thing, which is 2 square roots of 30. And that's okay. In the next one, let's see, how many more? Okay, so I'm almost done. Yeah, I'll just finish this up then. We have 2 times negative 4 is negative 8. We have 5 times 10 is 50. Breaking it down, we're going to get 25 times 2, and we'll get 5 times 5. So my negative 8 is the original thing out front. We'll leave the negative 8 out front. We'll circle the group of 5s. So that comes out of the radical. And we have left over the 2. So we get negative 40 square roots of 2. And we are done. All right. Number 35. This one's going to be quite a large number. Let's see what we get. We get 5 times negative 3 is negative 15. And then we have 15 times 20, which ends up being 300. Notice I'm doing all this without a calculator. This is quite simple math, so you should be able to do this math even if you do some off to the side. Like, for instance, 20 times 15. Well, 20 times 10, right? 20 times 10 is 200. And then 20 times 5 is half of that, which is 100. So this is a total of 300. So you should be able to do this math off to the side. You shouldn't need a calculator. Let's see. 300 is 3 times 100. And 100 is 10 times 10. I'm going to stop there because I see my group of 10s. So my original outside the radicals, negative 15. I'm going to add to it I'm going to multiply it by that 10, the group of 10s, and then what's left over is the square root of 3 under the radicals. So negative 150 square roots of 3. That's my final answer. 36. We have 2 square roots of 80. Clean that up. And I'm going to break that into, I could do, let's see, 40. I could do 40 times 2. I can do 8 times 10. Let me do 8 times 10, which is going to be 2 times 4, which is 2 times 2. And 10 is 2 times 5. So there's a lot of 2's here. Let me be very careful. I have the original 2 that's out front, right? That's out front. So I'm going to use that one. Whoops. Again, I'm going to keep the 2 out front. Now, I have a group of 2's here, and I have a group of 2's here. So I'm going to do another 2 and another 2, because I had 2 groups. Nope, I'm trying to get that. There we go. Okay, so those are my groups of 2 that I pulled out, along with the original 2 out front. Now what do I have left over is, whoops, not that 4, I'm sorry. All I have left over is a 5. So it looks like 2 times 2 is 4 times 2 is 8. 8 square roots of 5. And I'm done. Awesome. Up until 36, you should have accomplished all of the adding, subtracting, and multiplying, along with simple, what's the date? 28. Along with simple, solving these simpler ones, where there's no addition or subtraction or multiplication. Now we're going to move on to division, and that's pretty much the most difficult one. We have about a page of these. Oh, and there's some distributing ones. But let's just get through numbers like number 38 and so on. Number 38, the square root of 4 is 2. It's a perfect square, so I'm just going to write it right in the numerator. We have 5 times the square root of 36 is 6. So we have 2 over 30, which ends up being 1 over 15. I'm going to keep it as simple as possible. If I don't need to multiply it by anything, we're going to keep it just like that. 39. This one looks like 15. Well, let's look at the factors of 15. 5 and 3. Neither of those work. We're going to leave it just the way it is. But the square root of 16 works really well. It's 4. So we're going to get 5 square root of 15 over 3 times 4. So we get 5 square root of 15 over 12. And we are done. Number 40. Oh, this one. Okay, so in this case, we have a really nasty number happening here. We have a 3 in the numerator. We have a 48 in the denominator. These are radicans. Um, I have a few options. What I'm allowed to do is I'm allowed to write it like this if I want to. 5 times the square root of, now 5 being in the numerator, so maybe call it 5 over 1. Let me call it 5 over 1. Imagine there's a 1 down here, right? So I have 5 over 1 times, and I can put the square root of 3 over 48. I can actually combine it, clean it up, and then reduce it. I can get rid of 3 up top and 3 in the bottom as long as it's a multiple of 3. So it's really up to you what you want to do with these. The rules allow for us to do a few different things. But let's say, let's go back. Let's, instead of writing it under the same radical, let's say there are 3, let's write it like this. 5 square roots of 3 over 48. 3 times 16. 16 times 3 is 48. Why did I do this? Well, take a look. These simplify to be the number 1, which leaves me with 5 over the square root of 16. And the square root of 16 is a perfect square. It's the number 4. So my result is 5/4. That is one option for solving this. Another option is to write it, is to multiply it by the square root of 48 over the square root of 48. That to me is a little bit more work. What I do is I'm allowed to do what's called this idea is called rationalizing. Rationalizing is when I take the denominator and I multiply the numerator and denominator by the denominator. Why would I do that? Well, ignore this for a second. The number square root of 48 over the square root of 48, that is the number 1. So I can multiply anything by 1 and it does not change its value. It's not an equation, so I'm only allowed to multiply it by 1 because I'm not allowed to change its value at all. In an equation, you're allowed to change the value on one side of the equation and on the other. You have to do it as a magnifier. You can multiply by the same thing to both sides, or you can divide the same thing. In this case, I can't just multiply one numerator or one denominator by a number without changing its value, unless they're both the same thing, like, for instance, what I have here. So I'm going to multiply this by the square root of 48 over the square root of 48. What you'll notice is that the square root of 48 times 3 is 144. And the square root of 48 times the square root of 48 multiplied together is a really large number. It's 2,000. Wait, let me get my calculator. 48 times 48 is 2,304. But you know what I know about this? I don't need to really simplify it. I don't need any extra work to simplify it because the square root of 144 is 12, and the square root of 2304 is going to be 48. I know this because 48 times 48 are the two factors that I multiplied together to get 2,304. So it's going to break down into 48 times 48 if I do my factor tree. So we have 60 over 48, which divide each by 12, you get 5 over 4. We have the same answer. It doesn't matter how you solve it, as long as you follow the rules of radicals. So we're allowed to rationalize by multiplying the denominator by the same denominator and matching that with the numerator. If the denominator was the square root of 5, you would multiply numerator and denominator by the square root of 5, and you would totally get rid of it from a denominator. You would get the square root of 25 in that denominator, and then you would have the number 5. So that's what rationalizing allows us to do. Either way is right. So I'm going to let me label this option 1. Whoops. option 1. Here's option 2. All right. Looks like I did this one in class. This one I chose to write under the same radical. Here's what's really cool. If you write something under the same radical, you immediately, what's 15 divided by 3? 15 divided by 3 is 5. So the square root of 15 over the square root of 3 is the same thing as the square root of 15 over 3, which the square root of 15 over 3 ends up being the square root of 5. So you'll notice that's where I go from 4 times the square root of 15 over 3 to immediately 4 times the square root of 5. And that's it. That's just another way you are able to write it all under one radical. All right, this one's a little bit more simple. We get the square root of 4 is 2. The square root of 36 is 6. 1/3. It simplifies to 1/3. Again, let's say you put it under one radical. Check this out. 4 over the square root of 36. Well, that's equivalent to, what's 4 over 36? Well, that's 1/9, right? 9, 18, 27, 36, 1/9. Then you break it back up into the square root of 1 over the square root of 9. Well, the square root of 1 is 1. Square root of 9 is 3. You have the same answer. That's another option for solving it. The last option is by rationalizing, and that's by multiplying by the square root of 36 over the square root of 36. You know what? That number is going to be so crazy and large. I'm not even going to show you that example. That is still another possibility of solving it. Okay, 43. This one, 3 over 15. I don't really like it. I could write it like this, and then simplify it to 1/5. I'm still not getting anywhere though. Notice you still have a radical when you break it up in both the in the denominator there. So let's not take that path. Let's just rationalize and fix it right away and then work from there. So I'm going to multiply it by the number 1. But it's going to look like this. Why would I do this? Well, I get the square root of 45 and I get the square root of 225. Ooh, the square root of 225 is the number 15. Notice the square root of 15 times the square root of 15 is the number 15. Or at first it's the square root of 225, and then it ends up being the number 15. So I have the square root of 45 over 15. But wait, 45 can be simplified as well. So we get, for 45, we're going to get these two things. So we got 15 times 15. That's what got us our 15s. For 45, we're going to have 9 times 5, and we're going to have 3 times 3. So in the numerator, I'm going to write my group of 3's outside, and my 5 on the inside. That's going to stay over 15. 3 over 15 simplifies to be 1/5. So this is my final answer. Or I could say square root of 5 over 5. They're equivalent. It doesn't matter if there's a 1 there or not. So I simplified to the square root of 5 over 5. Notice I could have got that if I just rationalized this. If I rationalized, if I simplified, right, 3 over 15, I quickly get 1/5, which means it's the square root of 1 over the square root of 5. And then I rationalize. And I'm exactly where I was before by rationalizing. So that will get you there, but I would have just rationalized that one. Okay, 44. This one you're going to have to rationalize. 2 and 3, it doesn't matter how I write it. Whoops. Notice this doesn't work, right? I'm back at the beginning. So all I'm going to do is rationalize. I'm going to multiply by the denominator in both the numerator and denominator. The number 1, right, you can multiply by the number 1. So I get 3 square roots of 6 over the square root of 9. And that's going to give me an equivalent of 3 square roots of 6 over 3, because the square root of 9 is 3. And then I do this, and I get the square root of 6. And I'm done. Who would have thought that that was the square root of 6? Much more simple than 3 square roots of 2 over the square root of 3. All right, we're going to keep going. I'm going to do a couple more, and then am I almost done with the whole worksheet? Okay, I guess I am. I'll try to do these a little bit quicker. Here's what I'm going to do for this one. I'm going to simplify it first. I'm going to call this 2 times 3 over 3 square roots of 15, because square root of 9 is 3. I'm going to cross these 3's out. I'm going to get 2 over the square root of 15. Whoops. Then I'm going to take 2 over the square root of 15. I'm going to multiply it to rationalize it. So I get 2 square root of 15 over square root of 225. And again, 225, I already know that what it's composed of. It's 15 times 15 because I got it from over here. So I get 2 square roots of 15 over 15. And I am done. That's my final answer. I can't simplify anymore. Here's what students make an error on. You cannot simplify this. You can't be like, oh, there's a 15 and a 15. That doesn't work because one's under a radical, one is not under a radical. So be careful. All right, 46. I'm going to multiply by the square root of 2 over the square root of 2. Let me see. And I'm going to get 3 square roots of 6 over the square root of 4. Square root of 4 is 2, so I'm going to get 3 square roots of 6 over 2. And that's it. That's its most simplified form. All right. This one. It might be easier to simplify it a little bit. There's 3 up here. That'll bring this down to a 2. So I really have 4. The square root of 3 went away because I got rid of 3 divided by 3. So I still have this. That's one thing I could have done. So think about it like this. 3, 6. They're both under the radical. That's 1 over 2. So it ends up being 1/2. The square root of 1 is 1. So this is implied. I don't need it. It's implied that it's 1. So that goes away. So that's one thing I could have done. And then I'm just going to multiply it and rationalize it. So I'm multiplying it by the square root of 2 over 2. So 4 square roots of 2 over 3 square roots of 4. That simplifies to be, I'll put it right here. 4 square roots of 2 over 3 times 2, which ends up being 2 square roots of 2 over 3. Maybe a little easier way. So it's 2 square roots of 2 over 3. Maybe an easier way was actually to not simplify it and to just rationalize. So 4 square roots of 3 over 3 square roots of 6. If I just multiply it by the square root of 6 over the square root of 6, I get 4 square roots of 18 over 3 square roots of 36. And I get 4 18 breaks into 9 and 2, and 36 ends up being 6. So we have 4 times 3 square roots of 2 all over 18. So 4, 8, 12 square roots of 2 over 18, which ends up being 2 square roots of 2 over 3. We are exactly where we were before. So it doesn't matter what method you use. I am going to erase, no, I'll leave it. I'll label it option 1 or option 2. I'm running out of room. I'll just label that one as option 2. Okay, this one, 48. You have to rationalize. Oh, you know what? I didn't really explain. See how I'm multiplying by the square root of 2 over square root of 2? See this 3 here? You don't have to multiply by that. Here's what happens. Let's say I do match the exact denominator, right? Let's say I do this. Okay, what's going to happen later on? This, right? We're going to end up simplifying 3 over 3. 3 over 3. So why put a 3 in the numerator and 3 in the denominator? They're just going to go away again, right? So, I mean, I can match the exact denominator because you're like, hey, Mr. A, look at this 3. That's fine, but you're causing more work for yourself because the 3's go away later on. So all you need to do when you rationalize is multiply by the square root of 2 over 2. Only the square root that's going to make an effect or an impact on it. So here we go. We get 2 square roots of, we get 2 square roots of 2 over 3 square roots of 4. And what that's going to do, now the 4 goes away. The square root of 4, we no longer have that radical in the denominator. That's what we're looking for. We're looking to get away from that. So again, if you multiply by your 3's, they're going to have to go at this moment. But we didn't, so only the 2's are going to go. And we are left with the square root of 2 over 3. And we're done. The key when you're doing division is to always get rid of that radical from a denominator. We do not want a radical in our denominator. I'm going to add that to our notes. We do not want a radical in our denominator. So I'm going to put this. To multiply or divide square roots, we must have the same index. Oops. But our radicands can be different. We just multiply them together. Oops. But our radicands can be different. We just multiply these together. Together. And then our last note, and simplifying division, I'm going to use big boy words, quotient. So when simplifying quotients, we want to ensure that there are no radicals or square roots left in the denominator. That's the most important part. The way to simplify a quotient or a division, right? Quotient's division. We want to make sure there are no square roots in the denominator. Actually, we want to make sure there's no radicals, whether it's square roots, cubic roots. In our particular example, we're using square roots, so we want to make sure there's none left in that denominator. All right, so and that's all of the notes. Now, there is one more thing here, and I'm not going to do them all out. I'll do one or two of them, but we want to make sure that we know how to do them. It's what happens if we're distributing a radical. Well, it follows the same rules as before. So the square root of 6 times 3 square roots of 5, you literally leave your 3 and you just do your 6 times your 5, which is your 30. And then we're going to do 4 times the square root of 3 times the square root of 6. So we're going to get plus 4 square root of 18. Now the important part is maybe I could combine them if they were the same. See how these are not the same? These are not the same. So it's not going to help me out for those. But let's say we can try to get them to be as simple as possible and then see if they combine. This is going to be 6 times 5, and this is going to be 2 times 3. So guess what? We have a 2, a 3, and a 5. These are all not going to work out. So the square root of 30 is going to stay the square root of 30. And 18 is going to simplify. We're going to get 9 times 2 and then 3 times 3. So we will get the 3's. So we get 4 times 3 square root of 2. So we're going to get here 12 square roots of 2. And it stays exactly like that. You just have to make sure you distribute to both things and then you simplify. So I'm not going to do those because I've done a lot of those. I just want to make sure that the answer is right. So we're going to go, this is number 49. So you go to 49. You notice that 49 is exactly that. What you will notice in all of these, 49, 50, 51, 52, 53, and 54, none of them can be combined. So don't force them to combine. Leave them separate. Get in your simplest term. See, here 15 and 3 are the simplest. 30 radicand, 20 radicand are the simplest. 10 radicand and 3, and so on. Sometimes they just don't work and they don't combine, so don't force them to. Okay? Well, that's it for the video. Hopefully you can get through the last 5 on your own. I think I've been doing this for a while. Let me just finish up quickly. I'm just going to do the work. -2 square roots of 10. And that's going to be -2 square roots of 12. I'm only going to simplify the ones that I know can be simplified. This first one can't. The second one is 4 times 3, which is 2 times 2. So we're going to circle those. We get -2 square roots of 10. It's going to be -2 times 2. That's my group. Square roots of 3. So this is what we have. And we get -6. Nope, we can't combine those. We are done. That is it. We can't go any further. Negative 2 square roots of 10 minus 4 square roots of 3. Okay, this one, we have negative 3 square root of 60, and we have plus 3 square root of 20. I'm going to use my perfect square here instead of using my factor tree. I get 4 times 15 is 60. I get 4 times 5 is 20. So this ends up being negative 3 times 2 square roots of 15 plus 3 square roots of 2. I'm sorry. Square root of 4 is 2. Don't make that mistake. Square root of 4 is 2, not the square root of 2. If you kept doing that, you would just keep going down and down until you got something that was not, where you couldn't find the square root of it. So I get negative 6 square root of 15 plus 6 square roots of 5. And I am done. Can't combine. This one, we have 5 square roots of 30. And I get minus 10 square roots of 100. Well, listen, the square root of 30 is 6 times 5, which is 2 times 3 times 5. That one's going to stay exactly the same. You can't simplify that. This one ends up being 10 times 10. So we get 5 square roots of 30 minus 100. And that is done. All right. This one, 3 square roots of 15. Then we have minus 5 square roots of 75. 15 is 3 times 5, so it stays exactly the way it is. 75 can be 25 times 3, so that one's going to get me somewhere. So it looks like it gets me, whoa, I'm messing all that up. 5 times 5 times the square root of 3. So I get 3 square roots of 15 minus 25 square roots of 3. And we are done. Can't be combined. And numero 54, we get 5 square roots of 12. And then plus 10 square roots of 2. 12 is going to be 4 and 3. Again, I'm using the perfect square method now, knowing that 12 is 4 times 3. So square root of 4 is 2. So we get 10 square roots of 3 plus 10 square roots of 2. And all those answers should be there. 10 square roots of 2. 10 square roots of 3 plus 10 square roots of 2. Then the one before that, 3 square roots of 15 minus 25 square roots of 3, and so on. All right. I hope this video helps. Feel free to ask any questions that you may have in class or at a different time, like come in during a PLT or after school. Just email me. But hopefully this supplemental video helped you with your radicals. Remember, you need to know your perfect squares. You need to be able to do them quickly and efficiently. So practice, practice, practice. I'll make a Quizlet so we can practice in class as well, or you can practice at home. All right, take care. I'll see you guys on Wednesday. Bye.